Now how to find out the dual graph of any planar graph? Yes, dual graph exists only for planar embeddings. So given a graph, first make sure you have drawn the graph without edge crossing. That is a planar embedding. Then only we can find out the dual graph of that planar embedding. So here this is a planar embedding of the graph K4 that is given to us. Now what we are going to find out is the dual graph of K4, that is K4 star. This is how we represent dual graph. Okay. What we will do in the given graph K4, you label all the faces. We know planar embeddings create faces on the plane, so that is bounded regions. So here in this planar embedding of K4, we are having 4 faces. See, this is a face X, this is a face Y, face Z, and of course the face that is outside. Let us name it W. So we are having 4 faces in K4, X, Y, Z and W. For your convenience, you may write W all the way outside around, because you have to make sure, you have to understand that the outside region entirely is the face W. Okay. Now in the dual graph, what happens is, as many faces are there in your original graph, those many vertices will be in the dual graph. So here you are having 4 faces X, Y, Z, W. So in the dual graph you will be having 4 vertices, and also you will name them as X, Y, Z and W. So these are the 4 vertices. Next, what about the edges? Remember, for every edge in the original graph, there will be an edge in the dual graph. That means as many edges are there in the graph K4, those many edges will be there in K4 dual also. So for each individual edge, we will draw corresponding edge in the dual, and that's how we will draw all the edges. So let's start with this edge, for example. So for this edge in K4, there will be a corresponding edge in K4 star also. Now where will it be? See the edge, see both the sides of the edge. See, every edge is going to have 2 sides, one side, another side. Every edge will have 2 sides. Okay. So for every edge you see both the sides, and on both sides you will find regions or faces. For this edge there is face X on one side, and on the other side of the edge you are having face Y. That represents that there has to be an edge between the faces corresponding vertices, that is X and Y. So between X and Y you are going to draw an edge, and this edge corresponds to this particular edge. Okay. Next, suppose we come to this edge. Now corresponding to this also you will be having an edge in the dual. Now this edge is having face X on one side and face Z on one side. That means the vertices corresponding to these 2 faces, that is X and Z, will be made adjacent. That is the reason I tell you ki the names you use for the faces in the original graph, same labelings you should use for the vertices in the dual graph. Okay. Next, come to this edge. It is having face Y on one side and face Z on the other side. So Y and Z will be made adjacent corresponding to that edge. Come to this edge. It is having face Z on one side and face W on the other side. So Z and W should be made adjacent. This edge is having face X on one side and face W on the other side. So X and W are to be made adjacent. This edge is having face Y on one side and face W on the other side. So Y and W are to be made adjacent. Okay. So few things that you have to remember. First, in the original graph you label all the faces, and remember the outside region is also a face, and for your convenience you can name W, 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 means the outer face labeling everywhere you can. Okay, that's up to you. Just remember the outside is the same face W, and for every edge in the graph you will have an edge in the dual graph. So there are 6 edges in K4, you are going to have 6 edges in the dual also. Now after you draw your dual, how to cross check that it is correct? You will see as many vertices are there in the original graph, those many faces will be created in the dual graph. As many faces are there in the original graph, those many vertices are there in the dual graph. As many edges are there in the original graph, those many edges are there in the dual graph. See, the graph K4 has 4 vertices. The dual graph of K4 also has 4 faces. Now how to see that it has 4 faces? Here there you are having an edge crossing. So if you draw the edges without edge crossing, then this is what you get, and that will help you get the faces. So here there is face 1, face 2, face 3 and the outer face 4. So there are 4 faces. In the original graph K4 there are 4 faces, and in the dual graph you have 4 vertices. Here you have 6 edges, and here also you have 6 edges. Okay, and another important criteria that you can check is every face is having a certain length in the graph. That corresponding vertex in the dual will have the same degree value. For example, here the face X is having length 3, 1, 2, 3. Corresponding vertex X in the dual graph is having degree 3, 1, 2, 3. Okay. The face Y is having length 1, 2, 3. So the vertex Y here is having degree 1, 2, 3. Face Z is having length 3. The vertex Z is having degree 3. Face W is having length 3, 1, 2, 3. And therefore W is having degree 3. So these are some things that you can check to conclude that your dual graph has been drawn correctly. Let's find out the dual graph of this particular graph. Now here we can see there is no edge crossing. So this is the planar embedding that is drawn here. So I can find out the dual graph. For that I need to label the faces. So here I have this as one face X, this is another face Y, and another bounded region is the outer region Z. There are 3 faces created. So in the dual graph G star we will be having 3 vertices. So I draw 3 vertices and I name them as X, Y, Z only, because corresponding to faces in the graph you are having vertices in the dual, so use the same labeling. Now corresponding to every edge in the graph you will be having an edge in the dual graph. This is an edge having face X on one side, Y on the other side, so X and Y will be made adjacent. So this is the edge corresponding to this edge. Fine. Next, this edge is having face Y on one side, this is face Y, and on this side it is having face Z. So Y and Z will be made adjacent. This is the edge corresponding to this edge. This edge is having face Y on one side, Z on the other side. That means there will be an edge between Y and Z. There is already an edge between Y and Z, but for every edge here there has to be an edge here. So if this edge also corresponds to the vertices Y and Z, so you are going to draw another edge between Y and Z. So here multiple edges may occur. This edge corresponds to Y on one side and the face Z on the other side. So again there has to be an edge between Y and Z which will correspond to this edge. So draw another edge between Y and Z. Okay. Next, which edges are left? This one is left. Here it is having X on one side, Z on the other side. So make X and Z adjacent. Next, this edge is having X on one side, Z on the other side. So X and Z are to be made adjacent again corresponding to that edge, because edge count will be same. Okay. Next we come to this edge. Now see, this edge is having face Z on one side and again face Z on the other side also. That means there has to be an edge from Z to Z. That means there will be a loop. Okay, whenever you have the same face on both the sides of an edge, means it will create a loop at that particular vertex here. Again see, this is an edge which is having face Y on one side, face Y on the other side also. That means there will be a loop at the vertex Y. After you have drawn it, cross check. Here there are 7 vertices. Here there must be 7 faces. See, face 1, 2, 3, 4, 5, 6 and the outer one 7. So here there are 7 faces or regions. Here there are 1, 2, 3 faces. So here you have 3 vertices. Here you have 1, 2, 3, 4, 5, 6, 7, 8. 8 edges. Here also you have 1, 2, 3, 4, 5, 6, 7, 8. 8 edges. And you can check the degrees also. So you have the face X here having length 1, 2, 3. Okay. And here the vertex X is having degree 3. The length of a face in the graph is the degree of the corresponding vertex in the dual. So y is having length 1, 2, 3, 4, 5, 6. Here y is having degree 1, 2, 3, 4, 5, 6. Okay, and what about z? Z is having length 1, 2, 3, 4, 5, 6, 7. And here the vertex z is having degree 1, 2, 3, 4, 5, 6, 7. Okay, so this is how we can check our solution.